So now it's time for Paula Bustos from CEMFI and CPR, who is presenting a paper, Structural Transformation, Industrial Specialization, and Endogenous Growth with Juan Manuel Castro Vincenzi, Juan Morras, and Jacopo Ponticelli. Please go ahead.
Hi, thank you. Okay, so the paper I'll present is about structural transformation, industrial specialization, and growth. This is a joint work with Juan Morras, who is there, Juan Manuel Castro Vincenzi, and Jacopo Ponticelli. So the motivation for the paper is this view that the relocation of workers away from agriculture into manufacturing is key for development. This is a long observation by historians and development economists, and usually the arguments for thinking that this process is important for development and growth are two. On one side, there are the idea that this produces static gains. So the idea is that there is a productivity gap between agriculture and manufacturing. So the relocation of labor towards manufacturing is going to increase the level of output. A second set of arguments involves dynamic gains. So here the idea is that manufacturing is characterized by economies of scale, innovation, and knowledge spillovers. So a movement of a larger share of the labor force towards manufacturing is going to put countries in a faster growth trend due to these endogenous growth forces. We started thinking about this question and found that there is very little empirical evidence on these dynamic gains. So we thought to use an experiment we've used in our work in the past to try to provide some direct evidence on this process. So the idea of the paper is going to be to use the adoption of GM soy in Brazil as a natural experiment, in the sense that we'll treat this as an exogenous change in agricultural productivity that will have different effect across different regions, and that will allow us to trace the causal effects of this change in agricultural productivity on other sectors in the economy. And then the second idea is to use very detailed microdata to trace the effect of the shock across sectors and regions, which has a number of challenges, mainly because of the low level of disaggregation that we want to work on. So I'll discuss this, along the way. And the final step, after we have some findings on what are these effects, we write an open economy endogenous growth model to try to interpret and make sense of our findings. So that's all I'll show you today. And just let me preview the main finding of this paper is going to be that when workers living in the agricultural sector are unskilled, this structural transformation process can reinforce comparative advantage in low-skill industries, because from the point of view of the manufacturing sector, having an inflow of low-skill workers from agriculture amounts to an increase in the relative supply of low-skill workers. That induces specialization in low-skill intensive industries. If these industries are the same as low R&D intensive industries, which is what we find in the data, this is going to reduce innovation and reduce long-run growth. Okay, so a bit more detail on how we go about establishing these findings. Again, the empirical setting is going to be one where Brazil adopts this new technology in agriculture, and that is going to generate heterogeneous effects in agricultural productivity on regions that benefit more or less from this technology. And this benefit is exogenous in the sense that it's determined by how, soil and weather characteristics. So we can use this exogenous shock, to look at causality. So these regions more affected by this exogenous change in agricultural productivity face a faster reallocation of workers towards manufacturing that we established in our previous work. But here we have an additional finding, which is that the workers leaving the agricultural sector are mostly unskilled. So skilled workers are going to stay in agriculture, and these unskilled workers are the ones moving to manufacturing. The second finding is that this inflow of unskilled workers in manufacturing is going to induce a change in industrial specialization in these regions, because these workers go disproportionately to the lowest quartile of skill intensity and R&D intensity. So they really go to the lowest, the industries that have the lowest skill and R&D intensity. Next, we see that this has an effect on innovation. So what we will see is that this relative growth in the low R&D industries generates a relocation of innovation workers from these high R&D industries to these low industries. So we will, to look at this, we'll develop a new measure of, of the labor input in innovation to be able to trace these workers at this very high geographical disaggregation level. And we see this displacement away from these, good industries towards these worse industries. And finally, we look at productivity growth, and we find that these regions, experience this expansion in the size of the manufacturing sector, but a slowdown in manufacturing productivity. And this slowdown is driven by these high R&D intensive industries innovating less and having a lower productivity growth. Okay, so how do we make sense of these findings? We write a model. This model is going to be, have the minimum ingredients necessary
Paula,
to. Yes.
This is Marty. Before you go to the theory,
yes.
Just a comment on the motivation. So
yes.
I think that, if you look at the historical accounts of like the direction of innovation, for like, Britain and the US at the end of the 19th century, beginning of the 20th century, it just happened to be low skill intensive. So I'm complementing like low skill workers, not the kind of high skill workers. And I guess, and at that point in time, having like low skill workers leaving agriculture and going into manufacturing may have been like growth enhancing. So I guess it really depends on like the historical context in which you want to think about this, I think.
Yeah, definitely. Yeah, this is true, no? I mean, the first industrialization, wave in the Industrial Revolution clearly was replacing, artisans, no, who were high skilled by low skilled workers in the manufacturing sector, no? So that is a different story. So I think this is an interesting point. So it's possible that at that time this was not a concern, right?
Yeah. So I guess it's just because this happened in Brazil, like when like the technological frontier has moved far away from
yeah
that.
No, this is interesting actually. Yeah, this is interesting because actually if you think of the sectors where workers were in the Industrial Revolution, like textiles, these are the same sectors to which these guys are going now, right? But now these are the less dynamic sectors, which was not the case historically. Yeah, so that's a very, very interesting point. Yeah. Okay, so let me then tell you a bit about what do we do about the model. So the model is, going to have three sectors or three industries. One is agriculture, and then there's going to be two manufacturing sectors. The manufacturing sectors are going to be, one is we call it low skill, and the other we'll call it high skill manufacturing. The model is going to be describing a small open economy. We will use the model to think about Brazilian microregions. So the idea is that each microregion is going to have, be a local labor market. So labor is not going to be mobile across regions, and then there's going to be trade in manufacturing and agricultural goods across these regions. And there's going to be then 3 production factors. One is going to be land, and there's going to be also high skilled labor and low skilled labor. We are going to introduce endogenous growth forces in the model in a simple way. We'll think that innovation takes the form of an expansion in the number of intermediate inputs used in the high skill intensive sector. And then another key assumption is that these measure of inputs in this sector generate knowledge spillovers. And these knowledge spillovers spill over to the agricultural and the low skill intensive sector. So this high skill intensive manufacturing sector is going to be the source of knowledge spillovers to the other 2 sectors. So what do we get, in this model? The shock we going to put in the model is the adoption of this genetically engineered technology in agriculture. We'll model it as skilled labor augmenting technical change. And when we do that, we'll obtain the following 3 predictions. The first is that this is going to reduce the demand for low-skilled workers in agriculture. For this, we need 2 assumptions in the production function, which are quite natural. One is that land and labor are strong complements, and the other is that high and low-skilled workers are imperfect substitutes. So with that assumption, this increase in agricultural productivity is going to reduce the marginal product of unskilled labor in agriculture and then reduce the demand for this type of workers. The second prediction is that this generates an inflow of low-skilled workers into manufacturing, and this sector, this is going to generate this classic Rybczynski effect. This increase in the supply of low-skilled workers will reinforce comparative advantage in low-skill intensive industries and will expand output and employment in those industries. And finally, there is the endogenous growth part, where this is going to be a Romer-style effect, where the smaller size of this high-skill intensive industry is going to reduce the market for innovation, because innovation happens in these intermediate inputs, and the market is the high-skill industry using these inputs. So this shrinks the size of the market for innovation, and that will slow down growth. So that is going to be the basic setup of the model. We also have an extension which is going to be important to interpret our results, where both sectors innovate, but the only sector that produces spillovers or knowledge spillovers is the high skill intensive sector. So that's going to generate similar predictions.
Paula?
Yes.
David, one question. Do you want us to think of innovation or adoption, given that we're thinking about...
so that's interesting. So this is, this is important because of the context, right? We are thinking about, what happens in Brazilian microregions, right? So we think of this innovation as something that produces local knowledge externalities, right? So that's going to be key, that these local externalities are local, because otherwise none of the growth results are going to go through, right? So we need a local knowledge externalities. So we think of these, as this innovation as, solving problems or adapting imported inputs or intermediate inputs to the local, the local conditions, right? So you can think of, you need to figure out, ideas or problems, how to produce, textiles, or how to produce cars, how to produce, different goods in a certain region in Brazil. So we are thinking about that. So we are not thinking about innovation that is going to generate patents or traded goods, right? We think about innovation in this, sense that is more relevant for developing countries, know how you adapt the production process or inputs to produce certain goods in these areas. Because we, you know, the model is going to make sense to the extent that we are referring to local knowledge externalities, right? So that that is key. And then the other key is that, you know, there's very few patenting happening in, you know, in interior microregions in Brazil, for example. No? So we think more about this, yeah, I would say adoption, but that is very local in nature. Okay, so the literature that this relates to, you know, is the structural transformation, endogenous growth, and technical change and labor demand literature. So let me just say that, and then I'll discuss more in detail in the conclusion. Okay, so let me tell you a bit more about the background, the data, and our identification strategy. So, you know, the shock that we'll use is this legalization of GM crops by Brazil in 2003. The innovation on these crops is that they have a gene that is modified so that these plants are tolerant to an herbicide. So this is important for, you know, subtropical, tropical countries like Brazil, where, you know, weeds, you know, are, you know, grow a lot. And you know, made this technology very profitable, you know, all over Brazil, but especially, you know, as you can imagine, in more tropical areas. The second innovation is that this allows no tillage farming techniques, which basically is that instead of having to plow the land to remove all the weeds before planting, you can just plant the seeds in the residue of the last harvest, and then you put the herbicide and it kills everything except for the soil. So this, you know, reduces a lot the first step on the production process that was very much unskilled labor intensive. So that's why we, you know, characterize this technology as unskilled labor saving, okay? Which is going to be the main characteristics that makes it push, you know, labor out from agriculture into manufacturing. You know, despite this increase in agricultural productivity, the marginal product of unskilled labor is going to fall because of this strong labor saving characteristic of the technology. So, you know, just to illustrate the size of the boom that, you know, we're looking at, you know, here you see, you know, after the legalization, there's like a jump in the area planted with soy, which is our measure of adoption. And then at the same time, you know, you see a sharp reduction in employment in soy. But, you know, this reduction is concentrated in unskilled labor because, as you see, skilled labor is flat. Okay, so the employment of skilled labor doesn't seem to suffer, but, you know, employment of unskilled workers falls. And we define here as skilled workers as completed as 8th grade in, you know, middle school, you know, basically because, of course, in the Brazilian context, this is, you know, the relevant margin. In terms of, you know, how much population you have. Yes.
Yeah, I'm sure you would do this empirically more seriously to find out the decline, because there is a decline before that, but I'm more interested in the rise between 2000 and 2003. It looks like the sharp decline after 2003 is simply get rid of those sharp increase. Do you have any sense what's happening there?
I mean, if you look, so, you know, here you see that the area planted, so if you had, suppose, you know, I think probably a more interesting series to look at is, you know, workers per hectare, right? If you look at the workers per hectare, there's a sharp reduction, you know, right, you know, mimics this, you know, this series, right? In the series of aggregate employment, you're going to have the two effects. On one side, there's an increase in demand because the area planted with soy is expanding, okay? But within each hectare, you use less workers, okay? So this is what gives you this, you know, initial increase. But if you were to look at, you know, worker per hectare, you see a very clear, you know, reduction mimicking this series. We have that in the paper, that series. Okay, so how do we go about identifying the causal effect of this new technology, we will use a measure of exogenous technical change, which we source from this data from the FAO. What the FAO does, this data is well known, but just for those who might not know it, is to predict what are the potential yields for each crop in each corner of the world under different technologies. So what we do is we get, this is the map of Brazil and the yields with the high technology. And then this is the map, the one on the right is the map of Brazil with the yields under the low technology. And we just take the difference between those as, the increase in the potential yields of soy when adopting the technology, and superimpose the maps of Brazilian microregions, as you see, here, and that is going to be our unit of observation and the shock. So here, greener areas are areas where yields increase more because of adopting this technology, and these areas in red are areas where yields increase the least, or potential yields. No, these are the potential yields regardless of adoption. Something I will not show here is that these potential yields are a very good predictions of actual adoption that we show in our previous work. So this FAO data is a very good predictor of the adoption of soy in all these areas. Okay, so in this paper, what data will we use? I guess the main challenge is the level of disaggregation at which we work. We need to work at that level of disaggregation to really identify these causal effects of the new technology. So, a first source of data is the Brazilian population census, which is great, and in the sense that is representative both at the sector and microregion level. Okay, so here we can go quite fine in terms of sector and geographical aggregation. And this is going to include everybody, of course, including the informal workers. The main challenge we have is with the innovation data. Here, usually these surveys of innovation that exist in many countries are have small samples of firms, and they don't tend to be representative at small levels of geographical aggregation. So this is not, that is the same case in Brazil. This is not going to be representative at microregion level. However, we'll use it for computing a measure of R&D intensity at the industry level. So how do we go about solving this problem? Because we want to look at innovation, that's one of our main outcomes. So we had this idea of using social security data. So what we will do here is construct a new measure of the labor input in innovation. And the key advantage is that it's going to be representative at any level of geographical disaggregation, basically because we'll use the universe of formal firms. So I'll tell you in detail how we do that, but basically we use text analysis to investigate, which occupations are, the perform innovation tasks using a dictionary from the Ministry of Labor. And from there, we are going to classify them and then construct our measure of the labor input in innovation. So this is key for a developing country because, data on patents, for example, which could also be geographically disaggregated, is not relevant for the type of innovations that we're interested in a developing country context. And we think, because this type of social security data with occupations is available in many countries, this can be, done in many other contexts. So we think this is a nice addition of the paper to the literature. And finally, the way we estimate productivity is more standard. We use, a standard yearly, manufacturing survey, which again has a problem that is not representative at small levels of disaggregation. But in the case of Brazil, it covers the universe for firms larger than 30 employees. So that's the sample we'll look at. We'll restrict to this sample where we know that the survey is representative. Okay, so let me tell you a little bit about this new measure of labor. So what do? We basically digitalize the text of the descriptions of occupations from the Brazilian Ministry of Labor. We get, we have 2,500 total occupations, and then we define a set of keywords capturing innovation, tasks, using the description of innovation activities in the PINTEX survey, okay, which is the innovation survey. So this is the way we have to tie our hands in terms of not choosing keywords ourselves, but just using the ones in the innovation survey done in Brazil, which, again, has the issue of representativeness, so we cannot use it for our purposes. And then we use text analysis to identify occupations whose descriptions contains at least one of these keywords. And we get that around 10% of occupations are innovation intensive. Okay, so 251 of those are. So that's how we get our, so this is an example of, how we do the text analysis. I'm gonna skip it, it's in the paper, but just, in the interest of time. This is in Portuguese, so these are the keywords that we find, and these are the places where they are. Okay, so this new measure, the nice thing is that it's highly correlated. When we aggregate it at the sector level, we find that it's highly correlated with R&D expenditure per worker or the share of high-skilled workers. So as a validation, it seems to be a good measure of innovation at this sector level, for which the other surveys are representative. And the advantage relative to the traditional data is that it allows us to construct these maps where we have, in this case, we have exactly the input in innovation at yearly frequency in all sectors in all microregions in Brazil. Okay, so that's the main advantage.
Sorry, Paula, quick question.
Yes.
About how you're going to use this innovation data actually. So when you said before, you want to look at the expansion of intermediate inputs, I presume that some of those inputs will come from abroad as imports. So they're developed elsewhere.
Exactly, so that's the point. So what we care about is local innovation inputs. So we're gonna measure this is a measure of the local, so you'll see it a bit more in the model, but this is the measure of the local input in innovation activities, which is what is going to generate faster growth at the local level, because it will generate local knowledge spillovers. Okay, so we are interested in this local innovation input that might generate faster growth in certain regions than others. Okay, because these intermediate inputs are not going to generate these local spillovers. Okay, so the important thing about this innovation measure is that it depends on the local market size. So the market size at the microregion level. Okay.
Paula, one random question, but what's going on in the middle of the Amazon?
I know, we just constructed these maps, and we're wondering exactly the same. We need to take a look. This is weird. I think it must be, what I think is that probably there's very little formal, because this is only formal employment. So it's possible that in this area there's, very little formal employment, and there is some, sector that somehow ranks high in innovation that is present there. So we need to check. Yeah, because this is very weird.
Yeah.
So we need to check what is driving this data there. Yeah. Okay, so let me tell you what's the identification strategy we'll use, with this experiment and the data. So first, we look at the census data. This is decadal, okay, population census, to look at this reallocation of workers from agriculture to manufacturing. You need to look at census data, because of course most agricultural employment is informal, and the other data sources only cover formal employment. So the strategy will be to use population census data to look at the margin agriculture, manufacturing, and then to look in detail within manufacturing, we will use the manufacturing surveys and the social security data, which cover only formal firms, but that are a large share of employment in manufacturing. Okay, so with the census data, basically
Paula,
yes.
Just a clarification question. Do you have a distribution of these low-skilled workers across agriculture, manufacturing, and services? Presumably, a lot of them also could move into the low-skilled services, right?
Yes, so this is coming. You'll see.
Sorry.
This is coming.
Okay.
This is coming in a couple of slides. Okay, so let me just, I'll show you that in 2 slides. So this is delta Y is going to be the change in the outcome of interest. For example, what Rachel was suggesting, the employment share, of low-skilled workers in services, manufacturing, agriculture. And then, we'll just regress that on this exogenous measure of technical change, which is this FAO data on potential yields of soy. Okay, so this delta A, think of this as this change in potential yields I was showing you in this map coming from this FAO data. And then we have a set of municipality level controls that are going to control for differential trends across regions, that are more rural or richer, more literate, etc. Okay, so this controls for these differential trends because, of course, municipalities are not all identical in Brazil. And then we do something similar with yearly data, but when we go to the yearly data from the firm level, data sources, what we'll be able to do is, these are outcomes here, like, productivity, share of workers in innovation activities. But here what we'll be able to do, which is nice, is to estimate, because data is yearly effects. So we'll estimate the regression coefficient that is different for each year. And that will allow us to see whether, the timing of the effects, coincides with the adoption of soy, and, whether, the evolution over time, is consistent with the predictions of the model. Okay, so that's something we'll do with the yearly data. Okay, so let me show you the results on labor reallocation. So this is just a replication at the at the microregion level of the main results in our earlier work on structural transformation using this shock. So basically what we find here, you have that, the outcomes is the employment share in agriculture, manufacturing, and services, and this is technical change. Basically, we find that this shock reduced the employment share in manufacturing and relocated labor to manufacturing and to a lower extent to services. Okay,
sorry, the share, are they low skill share or the total share?
Total share. Now I'll split it by skill.
Okay.
Okay, so this is the total share. Okay, so let me, and these are large, let me just skip the quantification because I have very little time. So let me just go quickly to in terms of skill, and then we do the same but here we have the unskilled workers and here skilled workers. So this is the employment share in terms of unskilled workers. And here we see basically that unskilled workers mostly go from agriculture to manufacturing, okay? And when you look at skilled workers, you see, lower relocation, so the numbers are smaller, and they go mostly to manufacturing, okay, not to services. That's what we get here in the data. Okay, so the conclusion is that, most of the workers that relocated are these low skilled workers. I mean, there's some high skill, but mostly the relocation is of low skilled workers away from agriculture into manufacturing. Okay, and let me skip the results on skill premium. Okay, so the next question we have is, okay, there's this relocation of workers into manufacturing. Most of them are unskilled. So which manufacturing sectors are going to absorb this inflow of skilled workers? Okay, and when we look at that, we find a very striking result. Here we are splitting all manufacturing industries in 4 quartiles according to skill intensity. Okay, and what I'm plotting here is the coefficient estimates of the effect of soy technical change on the employment share of each of these industries within the manufacturing sector. Okay, and basically what we find is that all the increase in employment in manufacturing driven by, this agricultural technical change goes to the, industries in the lowest quartile of skill intensity, and the other industries are almost not affected. And, these same industries are the ones with the, the smallest level of R&D intensity. So workers really, like all of them, go to this sector that has a skill intensity that is quite close to the one of the agricultural sector. Okay, examples: footwear, wood products, alcohol, meat packing. Okay, they go to this type of industries. So the next question we ask is, what are the implications of this for manufacturing productivity growth? So we build a model to try to think about that. But because I have very little time, let me just show you, I'll show you just the setup of the model, or not even that, because I have 5 minutes, right? So let me just tell you, what the model
I can
does.
give you 7 if you want.
7, okay. So let me just, put the slide on the model here and tell you what happens in the model. The model, as I told you before, has these 3 sectors: agriculture, low skill intensive manufacturing, high skill intensive manufacturing. Agriculture is a standard, constant returns to scale sector, is, that uses land and skilled labor. So the idea here is that we will model, this soy, the adoption of this soy as unskilled labor augmenting technical change, okay? And under the assumptions, I told you about the elasticities in the production function, which are very natural, namely that labor and land are complements, and skilled and unskilled labor are substitutes. You get this very natural result that the adoption of this technology reduces the demand of unskilled labor in agriculture. Okay, so this pushes these unskilled workers to manufacturing, where you have 2 sectors. One is that is intensive in low skill labor, and the other intensive in high skill labor. And here you get the Rybczynski effect playing, where these guys are all absorbed by the low skill intensive industry, which expands, and the high skill intensive industry is going to shrink. Unfortunately, this high skill intensive industry is, the source of endogenous growth, right? Because it uses intermediate inputs, and the expansion of these intermediate inputs here, that are produced locally. So think of this production of ideas. These intermediate inputs that are produced locally are the source of knowledge in this economy. And the spillovers generated by, these intermediate inputs generate, a growth in low-skill manufacturing and in agriculture. Okay, so are the source of growth in this local economy. So these are local knowledge spillovers. So what you will get then is that this expansion of the, bad industry, or the low-skill intensive industry that doesn't have these knowledge spillovers, is going to reduce manufacturing productivity growth. So the model is going to predict that this improvement in agricultural productivity will generate static gains, but in the long run is going to reduce output as productivity growth falls in manufacturing. Okay, so that's the basic mechanism on the model, and let me just skip all this part. Okay, so let me see how how we go about the data. So now what we will do is basically, look at what happened. So let me just tell you this. So we're going to do 3 things. So now we're going to see what happens in these micro regions that are more exposed to technical change. Okay, so we use the same empirical strategy I was describing before. So in this case, we're going to look at what happens with employment now with the yearly data on formal employment that we source from the firm level data. So this is going to be employment. And here we have this measure of exogenous technical change from the FAO data. And BJ are coefficients that we estimate year by year. Okay, so that's what we plot here, this beta J, these coefficients. So basically what we find is that, the same as in the census data, we find that there is an increase in employment in low R&D intensive industries, while high R&D intensive industries remain flat. Okay, there's no increase. So all these workers coming from agriculture are going into these low R&D intensive industries. So this is just, confirmation of a census data result with this different data source that, we could find something different because of the, formal versus informal employment. Next, we use our measure of innovation that we developed using this, the description of occupations in the Ministry of Labor dictionaries. And what we find, now we split employment in non-innovative occupations and employment in innovative occupations. And what we find basically is that, employment in non-innovative occupations, increases in the low R&D industry, and also employment in innovative occupations. And what happens in the high R&D industry is that they are, losing employment in innovative occupations. Okay, so what we interpret this as, the relative size of the low industry increases, and then employment in innovative occupations reallocates towards this industry that is now having, higher returns for innovation due to this larger size, okay, in a standard Romer type of endogenous growth effect. And finally, what we do is to look at manufacturing productivity. So here we go to the manufacturing survey that, has information on value added and compute this very simple measure of productivity, value added per worker. And again, look at the yearly effect of this soil shock on manufacturing productivity. And we find that, after the introduction of the technology, you see this slowdown in productivity growth in the manufacturing sector. And this is not driven by a compositional effect. You could think, oh, this is driven by the fact that you are expanding the, low R&D industries. But actually, is driven by a reduction in productivity on impact in the high R&D industry and, with a lag in the low R&D industry, okay? So this is consistent with our model where, productivity growth is driven by innovation in the high R&D industry. So you see the impact here, and you see it with a lag in the low industry, which benefits from knowledge spillovers coming from the high R&D industry. And let me just conclude, because I have 1 minute. So, what I just showed you is that, we try to produce some direct empirical evidence on, the effect of this structural transformation on growth. We use this introduction of this GM soil to document that technical change in agriculture resulted in expansion of employment in low skill intensive and low R&D intensive industries, a reallocation of workers in innovative occupations from high to these low R&D industries, and a lower manufacturing productivity growth in the long run. So the main takeaway is that, although the literature has emphasized the size of the manufacturing sector, when thinking that this relocation of workers from agriculture to manufacturing was good for development, we think that our findings highlight that the composition of this sector and the patterns of industrialization are going to be key to exploit these dynamic gains of structural transformation. And we think that this is not something that is particular for Brazil, but it has external validity, mostly because technological innovations in agriculture, adopted in developing countries, come from skill-abundant rich countries. So in that sense, this might, happen in other contexts, where these innovations push skilled labor away from agriculture into the industrial sector. Okay, thanks. I'll try to see if I can go back to seeing people now.
Thank you, Paula.
Yeah, my screen. Okay, yeah, I am seeing everybody now.
Is there any question from the floor?
I have 2 questions actually. One, would you be able to do some form of computation, maybe thanks to the model, saying how much of the increase in soil productivity is undone from a welfare standpoint because you lose, endogenous growth in manufacturing? And the second question I had was about, could you have some like another effect, which is that you could have some of the innovative resources being actually going to the agricultural sector potentially, like being high-skilled workers or capital going to that sector, and that would deplete the manufacturing sector.
Yeah, that's interesting. So the first question, we haven't done all the steps of the quantification. No, what we've done is just one step, which was looking at how the increase in the, that's in the paper, no, how the increase in the relative size of the, of the low industry relative to the high, how much that reduced the growth, no, the growth rate. Mm-hmm. But we could do a full calculation by looking at also the differences in, I guess, output per worker, right, in manufacturing and agriculture, and look at the static gains, and then compute the dynamic gains and see how many years you get until, you get a reduction in output. We haven't done the full calculation, but I think we can definitely, that's a very good idea. We should try to do that.
Let me step in with just one quick thing. For this is key how you discount the future, right? Which will drive much of, which I mean, you can make whatever assumption, right? But that's,
Well, but we can at least have some indication, And then the second question, what was that? I forgot, I'm sorry. Competition
for innovative resources between agriculture.
Oh yeah, agriculture and manufacturing. Yeah, that is very interesting. The problem is that, okay, so the drama here we faced for this project is that it's impossible to measure innovation in developing countries at the level of disaggregation we need to identify causal effects, right? I mean, there's no data. And the data that we created using the social security data, we created this, that is good only for manufacturing, because the share of employment that, well, actually, I'm thinking that maybe, I mean, the share of employment that is formal in agriculture is extremely low in Brazil. However, what is true probably is that workers that do innovation in agriculture might be formal actually. So maybe we can do something, because we don't like to use the social security data to look at labor flows between agriculture and manufacturing, because it's absurd. You capture very little. However, for innovation workers, this might not be so bad. So maybe we can, that would be a good idea actually, to look at that. We didn't think about that,
Paula,
any other question?
I have a comment, which is I think, so like the model that you showed us, if I understood it correctly, it relies a lot on the local nature of spillovers.
Yes.
And so I was wondering whether you can exploit, like perhaps, for example, for this example that you were discussing about agriculture, perhaps this innovation in agriculture happens in, like certain places in Brazil, and then, kind of like it diffuses everywhere, where they try different fields, right? Like they did in India with the ICRISAT, for example. And perhaps for other certain like industries, like you would think that the knowledge is much more, like knowledge spillovers will be very dispersed, and some others it won't. And I don't know if you could use these to help you, I don't know, like identify better these effects. It's a vague comment, but.
So you're talking about the knowledge spillovers in agriculture? Or?
No, more generally, like for example, across industries in manufacturing. Originally, I was thinking.
Okay. So what was the idea of how to do it?
So for example, like manufacturing, I don't know, like you didn't describe exactly which industries, but say like I don't know, like like I said, like textile versus, I don't know, like some metal manufacturing may have different types of innovation process. Like you would think that the spillovers in terms knowledge spillovers would be like very different.
Oh, that's
for example, the linkages in input output that they have, and so on, right?
Okay. So try to document a bit better these local spillovers exploiting input-output leakages. That we could do, for example. Yeah, that's a very, very good idea, actually. That will give us a measure of where you expect these spillovers to be larger or smaller, and then we will find different effects.
So, for example, if you have like regions that are far away but perhaps connected through input output and so on, that perhaps could give you like some extra. I mean, input output would be one. I don't know if you could use like measures of like, for example, patterns and so on to know like, you know, like distance, and you could use it, you know, like in the knowledge space from like.
We have the road, we have constructed the road distance, so we could also exploit distance in like physical distance. Yeah, that's a good idea, to try to exploit a bit more the data to document these spillovers. Yeah, we could do this. Thanks.
Okay, any other question? No questions, so we can use these 5 minutes for a break.